Alright. So they said in this question they said prove 1 over 1 into 2 over 1 plus 1 over 1 over 2 into 3 plus 1 over 3 into 4 plus n into 1 over n plus 1 is equals to n all over n plus 1. Notice that this kind of case, they are not telling you to divide anything or prove that anything is divisible. Here they are trying to prove that left hand side and right hand side is equal. I normally ignore anything I see on this except for the variables, the ones carrying the variables. So let me rewrite it. So I have 1 over n into n plus 1 is equals to n over n plus 1. This is going to be our last class on induction. So we treat the rest in class. So if I have this, to prove it, the first step, which is the base step, when n, or we say when the proposition n is equals to 1, I'll simply replace this to be 1 over 1 into 1 plus 1 is equals to 1 over 1 plus 1. So check it out. This is going to give me 1 all over 1 into 2 equals to 1 over 2. And you know that anything times 1, this is 1 over 2 equals to 1 over 2. So this is true. So for the second step, which is when P of n is equals to k, we will have 1 all over k into k plus 1 is equals to k all over k plus 1. This value that you see here is what I call the P of k. This is the P of k. This is just like when they ask you get 3 plus 1. 3 is this P of k. We've gotten it. Then the k plus 1 term is the next term. So k plus 1 is the same thing as saying P of k plus 1. So which is 3 plus 1 will give me 4. So when I get this 4, I will now prove that this 4, I got it from somewhere. But let that not confuse you. We've gotten this P of k, k plus 1. Now let's get for Pn. When P of n is equals to k plus 1, this will simply be the same thing as saying, remember we have n, this will simply be the same thing as saying 1 over k plus 1 into k plus 1 plus 1 is equals to k plus 1 all over k plus 1 plus 1. So everything here is n, everything here is n. So once I get this now, notice that this is the same thing as saying 1 over k into 1 times anything is the same thing. K plus 1 plus 1 is the same thing as k plus 2 is equals to k plus 1 all over k plus 1 plus 1 is the same thing as saying k plus 2. Everything I have here, this thing that I have here is what I'm going to prove. This is what you prove. This is what you are going to prove. So this is like when I now say 3, or let's say I do 2 plus 1. 2 plus 1, for I'm using it as an instance. 2 plus 1 will give me 3, Shebi. 2 plus 1 will give me 3. So what he's saying is simply, this is, let's say this is 2, P of k plus 1. What gave me 1? 1 is the next term. What gave me 1 is this value here. This thing that I have here is what I substituted to get this whole thing that I have, which I'm taking to be my term, the results. So I'll simply carry everything, which is what I call k plus 1 term. I'll carry it 1 over k plus 2 equals to. So everything I have here, and what is the value of P of k? Is the same thing as saying k over k plus 1. So everything I have here is what I'm going to use to prove this thing. Okay, to prove this thing. So I'll use this to prove this. So let's try to prove it. So let me write it well. So I will have k all over k plus 1. So you know why I'm teaching you this is so that you need to get that understanding so you don't confuse it. I've noticed most times the reason why students find it hard understanding mathematical induction is they do a lot of things that are not related, and it makes them waste so much time thinking this thing is hard. So see this, I'm going to prove everything I have here. If I finish solving this and everything I have here is equal to this, proved. So notice that when I have something separated by a positive sign, it calls for LCM. So I have sorry, what am I doing? See the value that gave me this. What am I doing? I have 1 over, yes, 1 over n, and it's going to be 1 over k plus 1 into k plus 1 plus. So this should have been, I neglected this. This should have been, this is 1. This side is k plus 1. Then, yes, this is it. Everything here is n, which is this n. So this is not supposed to be, so this is k plus 1. Very important. If you miss anything, there will be problem. So before I start proving, I normally check if I'm correct, everything here. So notice that if I have these two things, to find the LCM is the same thing as saying bring k plus 1, then bring k plus 1, k plus 1, k plus 2. If you divide k plus 1, this will give you 1. This will give you 1 and k plus 2. If you go again, k plus 2, this will give you 1, give you 1. So the LCM is k plus 1 and k plus 2. So I'll simply substitute that LCM. So I'll have the LCM to be k plus 1, k plus 2. So when this k plus 1 come here and gets divided, this will get out, this will leave, this will divide this. So I'll now have k into k plus 2. Then when everything here come here and divide, I'll have plus 1. So notice that, yes. So notice that what I have here, up here, is going to be something as saying k squared plus 2k plus 1 all over k plus 1, then k plus 2. Alright, I want to clean this part so we can continue. So I have, this is going to give me k squared. Let me write it. 2k is the same thing as saying plus k, then plus 1 all over k plus 1, k plus 2. It is mathematical induction that tests how much you know algebra and indices. So you see that somebody that don't know will be stuck here. So at this point you need to remember, at this point you are trying to look at what is possible from this. So I look at it, I see that k plus, so this is going to give me the same thing as saying bring k squared one side, k squared plus k, bring it one side, then k plus 1, bring it one side, all over k plus 1, k plus 2. So I will now say, let's continue. I will now say, what is common here? K, then I have k plus 1. K times k squared, k times 1, k. Then plus this side, I'm trying to factor out what is common this place. In fact, once you're able to factor the first one out, always replace the second one with what you have inside. Whatever you have here, that's what you have here. So I've said k plus 1. Then that means 1 should be here. So bring it together. I'll collect the outside, collect the inside one side. So k plus 1. Then k plus 1. So don't forget that it's still having a numerator and a denominator. So I just factored out the numerator. So this is the sentence. I factored out the numerator. So the denominator now is k plus 1, k plus 2. So notice I have k plus 1, I have k plus 1. So I'm left with k plus 1 all over k plus 2. And that is what I have here. Hence, I've proved it. Proved. So in simple terms, whenever you are treating mathematical induction, the two common things, in as much as they give you the base step, give you when you have the basic step, the hypothesis and the rest. But whenever you are treating induction, you need to have in mind two things or two type of questions. Is the question asking me to prove that something is divisible, or is he using style to ask me to prove that the left hand side and right hand side is equal, or are equal, or are they asking me to prove that something is divisible? So when something is divisible, the minute you do P of k, whatever you get for P of k, let's say I got P of k plus 2 equals to, let's say 2m. I'll simply make it so that P of k, the value that is for k, will be the surrogate formula. So this will be 2m minus 2. Then for P of k plus 1 equals to 2m. That is when I'm trying to do division. I will now say, anywhere I see P of k, replace it with this value. So I will now have 2m minus 2 plus 1 is equals to 2m. At this end, you will see that I now have minus 2 plus 1. I have minus 1. Then 2m equals to 2m. So what this means is that I can say divide both sides by 2. Divide both sides by 2. Notice we are using a random example. We are using random example so that by the time you do this, and notice that if this is 2 and this is 2, when I have P of k plus 1, it is no longer going to be P of k plus 1, because I know that anytime I have 2 plus 1, anytime I have an even number plus 1, it does not give me an even number. So 2 plus 1 is 3, 4 plus 1 is 5, 6 plus 1 is 7, 8 plus 1 is 9. So anytime I have an even number adding 1, it does not give me an even number. And remember that numbers that can be divided by 2 are even numbers. So the P of k here, I'm not going to do P of k. Rather, P of k plus 1. Rather, I'm supposed to have done P of k plus 2. I see it. So that this is going to be, when you did, yes, Shebi? Yes. When I did this, yes. So it's supposed to be P of k plus 2. So that by the time you do this now, you see that you are left with 0. So this is now 2m, which is the same thing as saying that 2 into m. Because if you divide this now, it simply means that 2 into m is equals to 2m, which means that it can be divided by 2. Proved. So you need to know this. Whenever they ask you to divide by an odd number, P of k remains divisible by P of k plus 1. If they tell you prove that something is divisible by an odd number, it means that what you will do, P of k plus 1 will work for you. But if they tell you to prove that something is divisible by an even number, you are no longer going to have P of k plus 1. What you make use of is P of k plus 2. So that is what you need to know. So this is for divisibility of induction divisibility. But when you are treating left hand side and right hand side, trying to prove equality, that it is an equation, induction equation. When you are trying to prove it, what you use is the minute you get P of k equals to, let's say, ak plus 1. Then the part where you now do P of k plus 1 equals to, let's say, a raised to power k plus 1 plus 1, which is the same thing as saying a raised to power k plus 2. This thing that you have here is now what you will prove. And how do you prove it? By using whatever value you have here and the value you have for this one. Add it up. If you add it up, do the algebra. If you do it well, you must get the same thing that you have here, which means that what I have here now, which is a raised to power k plus 1, then plus whatever value I have here, notice I'm using a random example, pk plus 1 should equal to everything I have here, which is, this, which is ak plus 2. So that is how you go about it. Then you now write proof, or you just say QED. That is quite easily done. So with this said, if you watch this video over and over, give it time and attention. I know I rushed it. You know, when we started, Maka was disturbing us. But if you watch it, give it time, take your time. I bet you that if you can go over it over and over, there's nothing about mathematical induction that is supposed to worry you or be a problem to you. Ever. Ever. So remember to like, share, subscribe. And once again, tell your friends about Sure A Academy. Academic Daddy, Sure A Academy. Bless.